this will be the last topic in the chemistry units. Okay, so we'll be going over that today, Tuesday, Wednesday, Thursday, and then Friday we'll do a unit exam review. Then you have Thanksgiving weekend. Okay, and then you'll be writing your exam on Wednesday of next week. So we'll be starting the next unit the Tuesday after the Thanksgiving weekend, but I never make, sorry, we won't be because that's a PE day. You guys don't have school. The Wednesday, the first day back after the long weekend for you guys, will be your unit exam. Okay. I will post the unit exam review package either late today or early tomorrow, so you can start having a look at that. Okay. That review package will contain some review activities and a list of key concepts and a practice test. Okay. Save the practice test for like after you've done a bit of studying. That way it can tell you more accurately what things you need to work on. If you do the practice test right away, all it will tell you is you need to work on everything. And then it will not serve its purpose. Okay, so make sure you've done your studying before you do the practice test. And kind of save it for last, and I'll include the key and all of that for it. Okay. All right, so that's what's coming up here for you guys. Last topic, mole equation. Okay, so the mole is a unit of measurement that we use, like liters or grams or anything like that. It tells us the amount of something, okay? But it's specific, okay, to essentially a number of particles, okay? Now, we know, of course, that atoms are tiny. We can't possibly count them all, right? They're too small to see, and even if we could see them, it would take you a lifetime to count the amount of water molecules in a teaspoon of water, okay? It would just be forever. So, what was done was kind of some calculating to figure out how many atoms of a material would be in a certain amount. That's a mole, okay? And so we're going to look at kind of how that works here. Okay? It's a unit we use in chemistry all the time. If we say we have a mole of something, we have exactly the same amount of this stuff, okay, in terms of number of particles as we would of a mole of something else. Okay? So if I have, for example, a mole of water, okay, I would have 6.02 times 10 to the 23 molecules of water. Okay, that's 6.02 with 21 other numbers that have thankfully been rounded off behind it. Okay, if I had 1 mole of calcium, I would have 6.02 times 10 to the 23 atoms of calcium. Okay, so if I have a mole of something, not on my face, okay, a mole of something, okay, I have this much of it. Okay, now, what does that mean in terms of mass? If I have a mole of, let's say, lithium and a mole of lead, are they going to have the same mass? Okay, so we have the same number of atoms, 6.02 times 10 to the 23, but remember that lead atoms are much bigger. They have more protons and neutrons and electrons, so 1 mole of lead is going to be much heavier than 1 mole of lithium is. Looking at your periodic table, if you can take that out, because you're going to need it today, okay? The mass of 1 mole of every element is listed on your periodic table. It is the atomic mass. Okay, so if you're looking at lithium, okay, the mass of 1 mole of lithium is 6.94 grams. Okay, so if you had 6.02 times 10 to the 23 lithium atoms, it would have a mass of just under 7 grams. Okay, that's the equivalent of having about 7 raisins in your hand in terms of mass. That's that many atoms of lithium. Okay, everybody with me there? Okay. So the mole is a unit for measuring the amount of particles. Okay, we're going to look at the relationship between moles, mass, which we just talked about, and molar mass. Right? So we'll be looking at how those are related, okay? And they're related by the mole equation. Right? So the mole equation looks like this. N equals little m over big M. because, well, chemists have to be difficult. Okay? There's 26 letters in the English language.
Is that first one? Yeah.
Yes. Okay? There's 26 letters in the English language, and they have a 3-variable formula containing the same letter twice. Don't know why. And the only other letter in there is the only other letter in the alphabet that sounds like the one they have two of. N equals little n over big N. Okay? They just got to be difficult. All right? So that's what we'll be looking at a little bit later on. We will have to do a little bit of algebra. That is manipulating of this equation. Right? I'll show you how to do that. It's not hard. Okay? And then we'll get into solving those kinds of problems. All right, so we can express the amount of a substance in grams or in moles or in liters even if we wanted to, okay? It could just as well be liters, tons, molecules, whatever, but we can't obviously count the number of particles, so we're using a representative number, in this case, the mole, which, because we're so very busy, is abbreviated, mole. Take the E off and save yourself 25% of the time it would have taken you to write the whole word, okay? You laugh. Our society is so busy, we have an abbreviation for the word at. True story. Okay? All right. So, in the same way, okay, a dozen always represents how many? 12. Okay, well, a mole always represents this many. It doesn't matter what I have, 1 mole is that many. Okay? Whether it's atoms or molecules, it's that many. 6.02 times 10 to the 23. Okay, so a mole works just like a dozen. It's always the same number. Everybody good with that? Okay. All right, now, how did we arrive at this number? Well, people realized atoms are really small. We need to have a representative number of things to deal with these really small particles and thus really incredibly large numbers. Okay, so what they did is they took 1 gram of hydrogen, because it was the simplest atom. It's made of 1 proton and 1 electron. And they figured out, based on the mass of an electron and the mass of a proton, how many atoms would be in 1 gram of hydrogen. And made that the number. And that's what it ended up being. Okay, which is why the molar mass, okay, or the mass of 1 mole of hydrogen is just right around 1 gram. Okay? Everybody with me there? And then from there, they figured out all the other ones. Okay. All right. So this number was determined by a guy named Avogadro. I'll show you a picture of him later. Okay. I'm not sure why he picked the mole as the name for this unit, but when you see his picture, you might side with me on the fact that that was probably his nickname, because he looks like a mole. Okay. He really does. Kind of like big bulbous eyes and weirdly shaped shoulders and neck. Anyway. All right. So the mass of 1 mole of a substance is known as that substance's molar mass. For elements, we read that off the periodic table. So for hydrogen, it's 1.01 grams. Okay? But if it's for a compound, we'll have to calculate it, because obviously the molar masses, or the mass of 1 mole, okay, of compounds is not listed on the periodic table. But it's not hard to figure out. Okay? For something like water, okay, that has 2 hydrogens and 1 oxygen, it's pretty easy to figure out what the mass of 6.02 times 10 to the 23 molecules of this stuff would be. All I do is I take the individual parts and add them together. Okay? How many hydrogens are in this molecule? 2. All right. Each hydrogen is 1.01 grams. So multiply that by 2 because there are 2 of them. And I add that to the molar mass of 1 oxygen, which is 16 if you look at the periodic table. Okay? That means that if I have 1 mole of water, it will have a mass of 18.02 grams. Okay? So the molar mass of water is 18.02 grams per mole.
Why are some of the numbers for the molar mass in the periodic table in brackets?
Because they are uncertain. Most of those ones that you're looking at in the lanthanides and actinides row, okay, those are either synthetically produced or are highly unstable, and as a result, they don't last very long. So any measurements that have been made have been full of We know it's around that number, but we don't know what it is for sure. I won't make you do any that have those in. Okay. That sort of makes sense there, guys? Okay, how we would calculate the mass of 1 mole of a compound? Okay. All right, let's have you guys try, these ones here. Okay, see if you can calculate the molar mass of these 5 materials. I'm going to give you a couple minutes and we'll go through it together. Okay, remember all you're doing is taking, okay, the molar mass of each part and adding it together. Keeping in mind that sometimes you might have to multiply that by something if there's small subscript numbers. Okay, let's have a look at the first few here just to make sure we're on the right track. All right, so for sodium chloride, how many sodiums are in this? 1, okay. And the molar mass of sodium is 22.99 grams per mole. Okay, molar mass of chlorine, there's only 1 of them here. That's 35.45 if I remember correctly. Mine's like a steel trap. It's just always closed. Okay, so I got to add those two together. Okay, so we've got 22.99 plus 35.45. All right, so our molar mass is 58.44 grams per mole. Okay, how important are units? Very. Okay, in any answer that you do a calculation for, there should be units. If there aren't units, it'll be wrong. Because I won't know whether you're trying to tell me how many apples, oranges, old ladies with walkers, okay, whatever. Okay, if it doesn't have units, I don't know what it is. Okay, it has to have units. All right, for our second one here, we got iron, 55.85. Okay. Okay, and there's only 1 iron here, so that'll work. Okay, and then there's 3 bromines, 79.9. Times 3. Okay, so we got our 55.85 plus 79.9 times 3. Okay, so we have a molar mass there of 295.55 grams per mole. Okay, everybody all right with that one? Right, and people have done number 3. So for number 3, how many phosphorus do I have? 2, and it's 32.06? No, 30.97. Always get sulfur and phosphorus mixed up. Okay, 30.9, is it 9.7 on yours or 9.8? 9.7 on yours, okay. 30.97 times 2, okay? And then we've got 5 oxygen, so plus 16 times 5. 30.97 times 2 plus 16 times 5. So 141.94 grams per mole for the molar mass of diphosphorus pentaoxide. Okay. Now you're probably thinking to yourself, why is this important? Well, this is one of the things you need in order to use the mole equation. So molar mass is one of the parts of the mole equation. It's the capital M. Okay? And it's the one thing you can always calculate because you can always look up the numbers on your periodic table. So it's a number you would always have to plug into that formula. So we have to be able to calculate. How many people have done 4? Okay, I'll give you a couple more minutes to get 4 and 5 done. Remember, you're doing these piece by piece. So nitrogen, then hydrogen, then sulfur, then oxygen, okay, in order to get those. Okay, number 4. So we have ammonium sulfate, okay, here. And that's got lots of stuff in it. So we'll start out with the nitrogens. How many nitrogens are there? 2, right? There's 2 ammonium ions here. That means there's 2 nitrogen atoms. So we got 14.01 times 2, okay? Plus, how many hydrogens? 8. Okay, how many sulfur? 1. Is it 32.07 or 06 on your periodic table? 07, okay. And then for oxygen, we got 4 of those. Okay. Everybody Everybody with me so far? So then all we have to do is punch that in. Okay, so we're gonna have our nitrogens, that's, okay, them, and then we're gonna have our oxygens, or sorry, our hydrogens, 8.08, okay, and our sulfur, and our oxygens. All right, so we're looking at 132.17 as our molar mass for that, and that would be in grams per mole. Okay, questions on number 4? All right, for number 5, okay, we have scandium carbonate. So molar mass for scandium 44.96. 44.96. Okay, and how many are there? 2. Okay, plus how many carbons? 3. How many oxygens? 9, right. Okay, so it's really important to understand what those brackets mean, what we have to do with the numbers and the numbers in the brackets and all of that kind of stuff, okay, in order to get these numbers right. So 44.96 times 2 plus 12.01 times 3 plus 16 times 9. All right, so we're looking at 269.95 grams per mole for that. Okay, making sense? It's really just a matter of multiplying and adding. It's nothing really mathematically challenging as long as you remember what all the brackets and stuff mean. You really can't go wrong. Now, here's where people do go wrong on calculating molar mass. I give them the name of the compound instead of the formula. So I say calcium chloride, and they go, and then they calculate molar mass. What did they not do? They didn't drop and swap. They're not going to get the right molar mass, and nothing is going to be right after that. Okay, so making sure we drop and swap ionic compounds is crucial. Okay, so if we're interpreting a chemical equation, okay, when we're balancing the reaction, oftentimes the big numbers that we put in represent the number of moles. Okay, so we have 1 mole of nitrogen gas, 3 moles of hydrogen gas, and that's going to make 2 moles of ammonia. Okay, it could also mean simply I have 3 times as much of this, or 3 times as much of this as I have of this in terms of number of atoms. Okay, that could also be true. Okay, and if we're talking about mass, well, we would actually have to calculate what the mass of 3 moles of hydrogen would be. Okay, and calculate the mass of 1 mole of nitrogen gas. Okay, it'd be 28.02, and this would be 6.06. Then the mass of this would be those 2 combined, right? Because conservation of mass says your mass has to be the same on both sides. Right? So that's all that means. This is going to become much more important on the very first day of Chem 20. Okay? In Chem 20, you're going to do what's called reaction stoichiometry. Okay? Reaction stoichiometry basically means using the law of conservation of mass and the mole equation that we're about to go over in order to calculate the mass of materials that may be produced or involved in a reaction. Okay? So if you were making fertilizer, for example, which is what this reaction is used to do, okay, you might be asked, maybe a customer says, I need 400 tons of fertilizer. And you would have to figure out then from that how much nitrogen you would need and how much hydrogen you would need in order to produce that. You wouldn't want to buy more than you need. Similarly, you wouldn't want to come up short. Okay, so you would use an equation like this in a stoichiometry or mole calculation in order to figure out how much of each material you're going to require to meet that order. Okay, so there's real world kind of applications to something like this. All right. We already talked about that. That's Avogadro. Tell me that guy doesn't look like a mole.
That's him.
That's him. See like the eyes?
He's a baby hair.
Yeah, he does. Well, or he's just balding. Could just come forward. Okay, but I mean, look at, maybe it's just the cut of his suit. I don't know, but it looks like he has like a really long neck and no shoulders, kind of like a mole. Okay.
It's built like a pencil.
Yeah, yeah. Really strange. Okay. All right, so like I said, we could also use an equation, okay, if it was balanced to tell us the number of moles, 1 mole of nitrogen, 3 moles of hydrogen, 2 moles of ammonia. Okay, it could work like that. Okay, so that's the most important information that a chemical equation provides. The coefficients, okay, tell us the number of moles of reactants and products in there. That's why they have to be balanced. Okay. All right. So mole equation works like this. N is the number of moles. Little m is the mass in grams, and capital M is the molar mass, that thing we were just working on calculating. So we have to know all of those things, okay, or at least 2 out of the 3 of them, in order to use the mole equation, right? So originally, the way the mole equation is set up, it will calculate the number of moles. You simply divide the mass you have in grams by the molar mass, the mass of 1 mole, okay? So if I take the mass I have and divide by the mass of 1 mole, it'll leave me with the number of moles, okay? In the same way that if I said I have 5 donuts and I have a mass of 500 grams, each donut has a mass of, right? Okay? Or if I had each donut is 100 grams and I have 500 grams of donuts, how many donuts do I have? 500 over 100 calculates, okay, for me the number of donuts or moles, okay, as the case may be. All right, so if I need to manipulate this equation, what do? You have to move stuff around, right? Thank God nobody said, draw a triangle. If you were thinking that, keep it to yourself and never think it again. Triangles suck, okay? Here's why triangles suck. They only work for formulas that look just like this and have 3 variables in them. Beyond that, they are completely useless, okay? For example, in Science 10, we will use this formula. There's no triangle to help you with that one. Okay? No triangle where you can just cover up what you're looking for. There will be my equation. That's so dumb. Okay? I don't know who teaches that. But they make me very angry. Yeah. Okay? So we're not going to do that. Okay? I'm going to teach you how to do algebra. It's very easy. Okay? You need to know how to do algebra for a very simple reason. Triangles suck. Okay? And they'll stop working today. Okay? Another example, formula you would use if you took physics 20. It could be something like this. I don't think triangle is going to work for that. They don't account for square roots and things like that. Okay, so yeah, you have to give up on the triangles now. Okay, you're all done with triangles. Okay. Here's what you need to know in order to do algebra well. There are only 3 rules to algebra. Okay? No. And none of them involve draw a triangle. Okay? That's the rule for death. Okay? Draw a triangle, death. Okay? We're not going to do that. All right. So, rule number 1. Okay? To move something in an equation, okay, perform the opposite operation. Okay, so if I wanted to move something that was being divided, I would multiply. If I was wanting to move something that was being added, I would subtract. Okay, always do the opposite operation. That's rule number 1. Rule number 2 is what we call the golden rule of algebra. What you do to one side, you do to the other. Okay. Okay. Those 2 rules will get you through the mole equation. Okay. You won't even have to use the 3rd rule for the mole equation, right? Because it's all being multiplied and divided. Okay. But the 3rd rule, okay, you will have to use by the time we get to physics, okay, and that is move what's not attached to what you're looking for first. Okay, now I'll show you an example here that will involve using all three rules, just so you kind of get an idea of what I mean. Sorry, my penmanship is really bad, guys. That's only marginally better. Okay, so a formula that we'll use in physics, and if you're taking math this semester, you'll also use in math a little bit later on, is this one. It's used to calculate information about linear graphs. It's the graphing equation. Okay? Y equals m times x plus b. Okay. So if I wanted to solve for m, what should I move first? B, because b is not attached to m. Okay, so that's rule number 3. Move what's not attached first. Okay. Rule number 1 says if I want to move something, I have to do the opposite operation. B is being added, so to move it, I would subtract. Okay, so I'm going to subtract b. Well, positive b minus b is 0, so that's gone. Rule number 2, what I do to one side, I do to the other side. Okay, so then I'm going to end up with this. Y minus b equals m times x. Okay, I still need to get m by itself. And I'm multiplying by x, so what do I need to do to move x? Yeah, divide, do the opposite operation. So I divide this side, x divided by x is 1, and anything times 1 is itself. Okay, and what I do to one side, I do to the other. I've just done algebra. I didn't have to use a triangle. All I had to do was remember if I want to move something, I do the opposite, and I do it to both sides. That's it. Okay? Those 3 rules of algebra got me through university physics. They didn't help me with calculus one way, but they got me through university physics. Okay? They will get you through basically anything you will do in high school other than calculus. Calculus is just a totally different animal. Okay? But, okay, anything else you do, science or math, that involves manipulating equations can be done with those 3 simple rules. All right. For the mole equation, let's say I want to solve for mass, which is the little m. Okay, how do I get little m by itself?
You multiply by big M.
Exactly. I multiply both sides by big M. Okay, effectively that does this. Moves big M over there. Okay, everybody all right with that? Okay, so multiply both sides by big M, M comes over, big M comes over, right? That is the only manipulation of that formula you will have to do. You will never have to solve for big M in this formula because you can always get it from where? From your periodic table. So you will either use the mole equation in this form or that form. That's it. You don't need a triangle for that. Okay? Those are the only 2 forms you would need. Now, if I did want to solve for big M, I've already moved it over here. What would I do with M? Yeah, divide both sides by it. If I wanted to. I'm never going to have to, but okay, if I had to, that's what I would do. Okay? Fairly easy formula to use. Okay. There are only 4 ways I can ask you a mole equation problem. Only 4. Okay? I will go through all 4 examples today. I will go through a different 4 examples tomorrow. A different 4 examples on Wednesday. And yet a different 4 examples on Thursday. Okay? But there are only 4 ways I can ask a mole equation problem. Okay? I can ask for the number of moles. I can ask for the mass. Or I can give you the number of molecules and ask you to calculate the mass. Or I can give you the mass and ask you to calculate the number of molecules. Okay? Those are the only 4 ways I can ask a mole equation question. And I'm going to go over how to do each one. And you're going to have 4 examples of each one by Thursday. Okay? Should you go over those 4 examples knowing that there's only 4 ways I can ask you this question? Definitely, because I will ask at least 3 of them on the unit exam. Okay? If not all 4. Definitely 3 out of the 4, if not all 4. Because I'm still tweaking your test and I haven't decided yet. Okay? All right, so write this one down, because this is going to be our first example of a mole equation problem. How many moles of calcium chloride are in 90 grams? Okay, so there's going to be a certain set of steps that I'm going to be looking for you to show me in your getting to your solution to this problem. Okay? Each one of those steps is worth a mark, so you definitely want to show it. Okay? Your final answer is worth 1 mark. Okay? Now, obviously, if the only thing you write down is the final answer and it's right on a 4-mark question, you still get all 4 marks. Problem is, if you don't show your work and you just type something in wrong, and then write that answer down, what do you get? 0, because you showed me nothing on the way there. All I know is you wrote down a number that wasn't the number you should have got. And I can't figure out why, where you went wrong, okay, anything like that. Even though you knew full well how to do it, but just accidentally hit the wrong button on your calculator. Okay, and I have this argument time and time again with students. Okay, it's really important to show your work, it's really important to show your work, and they come up with all the same arguments all the time. I'm so smart I don't need to, and that might be true. Okay, it takes too long and I just don't want to. Not too bad. Okay, well, I don't get marks from showing my work on the diploma exam. You're absolutely right about that. But why not take advantage of getting marks for your work while you do? Okay, and showing your work is a good habit to get into. Okay, and if I'm looking over your work and you've shown your work, I can help you because I know where you went wrong. Okay? If you don't show your work, all I know is you don't know how to do it, and that's like a mystery. Okay? Then I don't know how to help you. So show your work always. Okay, first thing I'm going to want to see is what we call writing down your givens. That is, any values the question tells you. Okay? So the question tells me that it wants me to find out how many moles there are. That means I'm looking for n. Okay, because n in that equation represents the number of moles. Okay, and it tells me that the compound I'm dealing with is calcium chloride, which can help me to get what? Big M, exactly, the molar mass. Okay, so molar mass stuff is calcium chloride, so that's going to be 40.08, not 30, right? 40.08 plus 35.45 times 2, it should be 110.98 grams per mole, I think. I probably shouldn't do math in my head, but I'm pretty sure on that one. Okay. All right. There's your first mark. Calculated the molar mass and wrote down what the question gave you. 1 mark. All right, next thing you got to do, identify what formula you're going to use. Right now, this is the biggest gimme mark ever because you've only learned 1 formula so far in this course, and that's it. So it's a gimme mark. If you write it down, you get a mark for it. Okay? Later on in the course, you'll see why I give a mark for that. You know, when you've got a whole page worth of physics formulas to choose from. Picking the right formula means you understood the question. Okay? All right. Next thing we want to do is, if we have to, show our manipulation. Do we have to manipulate this one? No, it's already set up to solve for a number of moles, which is what we're looking for. Okay, so all we have to do is plug in our numbers. Sorry, we forgot one number. The 90 grams, okay? The other number they gave us. All right, so little m is 90 grams, so I'm going to plug that in here. Okay, and I'm going to divide that by big M, which was 110.98. You do not need to show your units in the calculation unless you want to. You're not going to lose marks if you don't. You're not going to lose marks if you do. All right. sometimes I give a mark for plugging in the numbers correctly. Not always, but sometimes. So it's not a bad idea to show. Okay, so we got 90 divided by 110.98. All right, so that gives us 0.81 moles. No. What decimal place do I round to? In general, what we do is we make sure our answer has the same number of digits as our least accurate number, which in this case is 90 grams. So my answer would have 2 digits. We call it significant digits. I'll talk about that later. Okay. But right now, I'm not too worried about how many decimal places you keep or don't keep. Okay. Actually, let's just say for now 2 decimal places. We'll do that until they teach us significant digits. That probably makes more sense to everybody for right now. Okay, so 2 decimal places for now. Okay, that's all there is to that question. Get a mark for the answer, provided it had units on it, which mine does. Mole. M-O-L. Okay, questions on how that one worked? That's as easy as they get. Okay, you don't have to manipulate the equation, you just have to plug in numbers in the right place. Okay, here's your second example. This one wants me to calculate the mass, so it's looking for little m. And it's telling me there's 4.5 moles. And it's telling me it's magnesium bromide. Okay, so on this one we were given the number of moles, 4.5, and we were told that it's magnesium bromide. So this is one like I was talking about on the last one. Okay, magnesium with bromine. And what do I need to do with this? Drop and swap. Okay, this is an ionic compound. Magnesium's a 2+, bromine's a 1-. So this is going to be MgBr2, okay, which is going to mean that I'm going to need to take my masses, so 24.31 for magnesium, there's only one of that, plus 79.9 times 2 because there are 2 bromines. Okay, so my molar mass is 184.11 grams per mole. Okay. All right, so that would be 1 mark. Next step, I got to identify the formula I'm going to use. Obviously, in this case, it's the mole equation. Okay. And I need to use the mole equation to solve for what? Little m, right? I'm looking for mass. Okay, in order to get little m by itself, what do I have to do with big M? I've got to, move it over to the other side. Okay, so this would be 1 mark, identifying my formula, and then I would get another mark for showing the manipulated formula. Okay, you wouldn't necessarily have to do what I did there, which is show, all right, first I multiplied both sides by m and then ended up over here. Okay, I mean, if you show that, great. If you don't, I'll know where you went wrong when you show me a manipulated formula. Okay, so I'd want to see the manipulated formula, big M times N equals little m. Okay, then we plug in our numbers. So our 184.11 times 4.5. Okay, so you might get a mark for that. Okay, and then we'll be looking at our final answer, 828.50 in this case. Grams. Okay. Generally circle your final answer. Okay. When I'm marking, if I can see your final answer quickly, okay, and it's right, I don't have to go any further than that. Okay. But it also helps me if I know where it is and it's not right to go backwards and kind of figure out where you went wrong. All right, so always a good idea to circle your final answer. questions on that one? Okay, that's the second easiest. Okay. The next two types that I'm going to go over involve an extra step because they now involve using Avogadro's number. That's 6.02 times 10 to the 23 number we were talking about before. Okay, now that 6.02 times 10 to the 23 represents the number of particles in one mole. That's what we need to remember. Avogadro's number, regardless of what material we're dealing with, represents the number of particles, be they atoms or molecules, in a mole of that material. Okay, so the next two questions will involve using Avogadro's number. Okay, so here's our next example. We are looking for how many molecules are in 600 grams of silver nitrate. Okay, give you a second to get that one written down. Okay, so as always, we want to start out by writing down our givens. Okay, we're looking for how many molecules. Okay, so I'm going to write number of molecules here in my givens and put a question mark beside that. That's number of molecules, not hashtag molecules, by the way, just in case anyone was thinking that. Okay, all right, are in 600 grams of silver nitrate. What did they give me? What's the 600 grams? Little m. All right, and the other thing they tell me is this stuff is silver nitrate, which can help me find big M, right, the molar mass. Okay, so big M, this stuff is silver nitrate. Okay, AgNO3. That's an ionic compound, so I need to double check that it's dropped and swapped correctly. Nitrate's a -1, silver's a +1, so yes, this is okay the way that it is written. Right, now I just have to calculate its molar mass. Okay, so 107.87. 107.87, there's one silver, okay, plus how many nitrogens? One. Okay, and 3 oxygens. Okay, so we got 107.87 plus 14.01 plus 48, which is 16 times 3. All right, so 169.88 grams per mole. All right, that's everything I know right now. The question wants me to find number of molecules, but I don't really have a formula for that just yet. What can I find right now with little m and big M? Number of moles, right? Okay, so that's actually what I'm going to find. Okay, I'm first going to calculate the number of moles, and that's going to help me calculate the number of molecules in just a minute. Okay, so the first thing I want to do is use what I have, calculate what I can using what I have. So n equals little m over big M. That's going to be 600 grams divided by 169.88 grams per mole. Like I said, you can write in the units, but you don't have to when you're doing your calculating. Okay, so I have 3.53 moles. Whenever you're doing, or whenever you're solving a problem, keep all of your numbers until the very end. Okay, you should not round off this number because we're still going to use it. Okay, and if we round it off, it takes away some of our numbers, and that can make our final answer less accurate. Okay, so as a general rule, we keep all of our decimals until the very end when we're at our final answer, and then we round. Do not round before that. Okay. All right, so 3.53, I'm not going to write them all, but I'm going to keep them in my calculator, okay, moles. All right, so now I know the number of moles, and I know Avogadro's number. Okay. Av's number is 6.02 times 10 to the 23. Now, we just said a minute ago that Avogadro's number tells me the number of particles in 1 mole. I have 3.53 moles. How am I going to figure out the number of particles?
You multiply the 6.02 times 10 to the power of 23 by 3. What we have in our calculator.
Right. Okay, you're going to multiply the number of moles that we just calculated, 3.53 with all the other numbers, by this. Okay, in the same way that if I asked you to do this. Okay, I have 3 dozen eggs. How many eggs do I have? Don't say 3 dozen. 36. How'd you do that? Yeah, you took the number of eggs in 1 dozen and you multiplied it by how many dozens you had. 3 times 12. You're doing exactly the same thing here. This is the number in 1 mole. This is how many moles you have. If you multiply those two numbers, you're going to get the number of molecules. Everybody follow? Okay. So that's what we're doing. Number of molecules, okay, is going to be Av's number, okay, multiplied by n. That will get me the number of molecules. Okay, so that's going to look like this. 3.53 times our 6.02 times 10 to the 23. Now, you're probably thinking, all right, how do I put that crazy number into my calculator? I'm so glad you asked. Here's how. You're going to have to use the exponent button on your calculator. Okay, your exponent button, okay, may look like this. It may just be a big capital EXP, okay, like that. Sometimes it's just a big E, okay. On the TI, it's actually 2 capital E's side by side, and it's the second function of the comma button, okay. So you want to look for that EXP, okay, or E, or sometimes you'll even see one that's like this, times 10 n or something like that. It will have that kind of a shape to it. So I can't remember what it is on the phone, on your iPhone calculator. We'll figure it out. Okay, so you're looking for one of those. Here's how you enter it in. Okay, in your calculator, you're going to take this number, like we said, and you're going to multiply it by Avogadro's number, which is always in brackets. Okay, so I put a bracket in, and then I go 6.02, and then I hit either the EXP button or the E button or whatever you have on yours. Okay, it could be 2 small E's as well. Okay, so I hit second function on my TI, and then the comma, and it gives me a little E. Okay, that little E means times 10, and the next number I put in is the power of 10. Okay, and on this one, it's 23 powers of 10. Okay, so that's Avogadro's number in your calculator. Okay, in brackets, 6.02, either hit your EXP or EE, okay, or times 10x button or whatever it is on your calculator, then you put in the 23 and close off the brackets. Okay? If you don't do that, your calculator will do a weird order of operations thing that will arrive at the wrong answer. Okay? All right. So, in that amount of silver nitrate, 600 grams, there are going to be 2.13 times 10 to the 24 molecules. So I would write my answer like this. Okay, 2.13 times 10 to the 24 molecules. Is that a lot? It is. Okay. Okay, anybody having trouble finding the exponent button on their device? Anybody got it? Good. All right, so that's the third way I can ask you a mole equation problem. The fourth way involves me giving you the number of molecules and asking you to find the mass. So it'll basically be backwards of what we just did. You'll start out with this step, except instead of multiplying, you'll divide, and then you'll work back from the mole equation to find mass. Okay, so that's this one. Write that one down, and then we'll walk through. Okay, so writing down our givens for this question. We're given the number of molecules, Okay, it's 1.54 times 10 to the 25. Okay, and we're told that it's diphosphorus tetraiodide. Okay, it's 2 and a 4. Do I reduce it? No, it's molecular. Okay, don't reduce molecular compounds. The prefix has said this is how many, that's how many. Okay, only reduce ionic compounds. All right, and the question wants to know what the mass is. So mass is my question mark. Okay, what I'm looking for here. All right, so P2I4. So we've got 30 point, is it 97? 30.97, okay, times 2 plus 160, no, 126.9 times 4. Okay, so that'll get us our molar mass for this question. Okay, 2 phosphorus and 4 iodine. All right, so we're looking at, oh, I missed, okay, I typed that in wrong. 30.97 times 2 plus 7. I keep going, this one's not 126, 126.94 times 4. Okay, 569.7 grams per mole. All right, so I know the number of molecules, I know big M, and I'm looking for little m. Okay, the mole equation says that number of moles equals mass over molar mass. And I don't have the number of moles yet. Okay, I obviously need number of moles if I'm going to get little m. How can I get n, the number of moles, using this number?
Divide that number by Avogadro's.
Exactly. Divide the number of molecules by the number of molecules in 1 mole, Avogadro's number. Okay? In the same way, if I asked you, I have 48 donuts, how many dozen do I have? You would go 48 divided by 12. Okay? Here we're taking number of molecules and dividing by the number of molecules in 1 mole. Okay? Same operation. So n equals number of molecules divided by Avogadro's number. Okay, so that will be 1.54 times 10 to the 25, okay, divided by 6.02 times 10 to the 23 is going to be more than 1 mole. A lot more. Okay, this number here is definitely bigger than Avogadro's number. Okay? Avogadro's number is only times 10 to the 23. This is times 10 to the 25. So definitely a bigger number. Okay. All right, so first we'll do that calculation. Both of those numbers have to be typed in the same way, in brackets. So 1.54 E25 divided by Avogadro's number, in brackets 6.02 E23. All right, 25.58 moles. Now, do I want to keep all those decimals? Yes, I'm not done yet. I'm going to have one more calculation to do, so I want to keep all of those. Okay, I'm not going to write them all, but I'm going to keep them in my calculator for now. All right, so now I know n, and I know big M. Can't I find m? Little m, sorry. Yes. Okay, so you've got a mark for your givens. You've got a mark for this operation here. Okay, mark for showing the mole equation. Now we have to manipulate the mole equation by doing what with big M? Right, multiplying both sides by it. So we're going to have big M times n equals little m. So you get a mark for that. Possibly you would even get a mark for this next step where you plug in your numbers. 569.7 plus, or sorry, not plus, times 25.58 with all the decimals. Okay, so I'm going to take this number and multiply it by 569.7. So again, I've kept all the decimals by using answer. All right, so I'm going to have 14,573.72 grams. Is that a lot? It is. It's 14.5 kilograms. It's a lot. Okay? That stuff, whatever it's used for. I have a lot of it. Okay? 14.5 kilos. All right, that's the most involved. Okay? That one would be definitely a 5-mark question. Okay? 1, 2, 3, 4, 5. Yeah. Okay, so definitely a 5-mark question. Yes. Okay, any questions on how that one works? All right. Okay, this is in your worksheet booklet, but we'll just work off of the screen for right now. Okay. Question 1A, don't overthink this. How many atoms or molecules are present in 1 mole of gold? This requires no calculation. Nope. That's its mass.
6.02.
Exactly. 6.02 times 10 to the 23. If I'd have said how many atoms of, or if I'd have said 1 mole of hydrogen, or sorry, 1 mole of, I shouldn't use hydrogen as an example, 1 mole of lithium, what would the answer have been? 6.02 times 10 to the 23. Okay? Everybody with me there? It wouldn't have mattered what I put there. Gold, lithium, hydrogen, water, potassium hydroxide. Okay? It would have been 6.02 times 10 to the 23 particles. That's how many of anything are in 1 mole. Okay? Doesn't matter whether I have a dozen donuts, a dozen nails, okay, a dozen eggs. I have 12 when I have a dozen. And the same is true for a mole. Anytime I have a mole, I have 6.02 times 10 to the 23 of that material. Okay. How would I calculate B? Now I don't have 1 mole, I have 2.5 moles. Exactly. Times Avogadro's number by 2.5. Okay? So I would take 6.02 multiply it by 2.5. Okay, there's my answer. 1.51 times 10 to the 24. Okay, and that was atoms. Okay. Everybody follow me there. How do I know if it's atoms or molecules?
Molecules if it's a compound, atoms if it's just.
Okay, almost all the time, yes. Molecules if it's a compound, atoms if it's an element, unless it's what kind of element? Special element. Okay, if it's a special element, like H2 or N2, it would be a molecule. Okay, if it asked me how many atoms are in a mole of oxygen, I would actually have to multiply it by 2. I'd first find the number of molecules, oxygen molecules, and then multiply by 2 to get the number of atoms. Okay? All right. So, what about C? How would I calculate that one? Because it says molecules. 10 moles of hydrogen molecules. So Avogadro's number times 10. That's it. Okay, because it asked molecules, not atoms. Okay, and for this one here, 0.628 moles of carbon dioxide molecules, 0.628 times 6.02. Okay, that's how you calculate number of moles. Avogadro's number. Okay. or sorry, number of molecules. Avogadro's number times the number of moles always gets you the number of molecules. All right, I want you guys to try number 2, okay? These will be simple mole equation calculations, okay? Using the mole equation. Okay, and in all of these, you are looking for n, so you don't even have to manipulate. Okay? Just have to calculate that.